Josh, what are you doing?
Oh, I'm just trying to understand this lesson.
What is it then?
Rules of inference and fallacies.
That's so very easy.
Really?
Yeah, don't worry, Josh. We can help you.
Thanks.
Come on, let's go.
Welcome to Mathematics in Modern World. My name is Twinkle and I am Coleen. Before anything else, let's define what is an argument. An argument is a sequence of statements that starts with one or more premises and ends with a conclusion. We say that the argument is valid if the conclusion follows logically from the premises. To help us identify what is valid or invalid, we will identify invalid forms. Basic valid argument forms are known as rules of inference. There are 7 forms of rules of inference: addition, simplification, hypothetical syllogism, conjunction, modus ponens or mode of affirming, disjunctive syllogism, modus tollens or mode of denying. Let us begin with the following example arguments. When the sun shines, I'm happy. The sun is shining. Therefore, I'm happy. Let's introduce the following propositional variables. Let P, the sun shines or is shining. Let Q be, I'm happy. This argument can be written as P implies to Q and P, therefore Q. Let's look at the table to see what kind of rules of inference is this. So this particular argument is called the modus ponens. Do you understand? See? It's so easy for you to be able to understand clearly the rules of inference. Let's have some examples.
Hi, my name is Mel. So for another example, let's have this argument. If we could travel faster than the speed of light, we could go to other solar systems. If we could go to other solar systems, we would meet aliens. Therefore, if we could travel faster than the speed of light, we would meet aliens. In this argument, let our P be if we could travel faster than the speed of light. Our Q would be we could go to other solar systems. Lastly, our R would be we would meet aliens. This argument can be formed to P implies Q and Q implies R. Therefore, P implies R. So let's go back to our table and see what kind of rules of inference is this. This argument is clearly an example of hypothetical syllogism.
I understand the rules of inference.
Very good, Josh. So now, let's move on to fallacies.
Is that right?
No, it's also easy.
Let's see.
Fallacies are incorrect reasoning which appear to follow the rules of inference but are based on contingencies rather than tautologies. The following are some types of fallacies. The fallacy of affirming the conclusion, which is based on the compound proposition, where P implies Q and not P implies P. The fallacy of denying the hypothesis, which is based on the compound proposition, where P implies Q and not P implies not Q. Circulus in probando or circular reasoning, which is an argument that uses a premise as the conclusion. Let's look at the examples.
First, let's have an example in the fallacy of affirming the conclusion. If it rained, then the street is wet. The street is wet, therefore it rained. Let our P be if it in Q, the street is wet. This argument can be presented as P implies Q, and Q, therefore P. It may look like the form of a modus ponens, but it's actually different. This fallacy affirms the hypothesis, which is the P instead of the conclusion represented by Q.
Hi guys, I am Chen. I have another example about the fallacy of denying the hypothesis. So let's take this argument. If you stop breathing, you will die. If you don't stop breathing, therefore you will die. So in this argument, RP would be if you stop breathing, and RQ would be you will die. So this argument can be formed as P implies Q and not P, therefore Q. If you look at it, it seems like the same with modus tollens. Instead of denying the conclusion, it denied the hypothesis.
The last one is an example of circulus in probando or circularism. The Bible is true because God exists, and God exists because the Bible says so. As you can observe, we're just going in circle, hence the name circularism. So Josh, you must be really careful in determining whether an argument is part of rules of inference or a fallacy.
Agree! We have to carefully identify which premises are hypothesis and conclusion.
Wow, yes. I feel confident doing my homeworks. Thanks, guys.
Bye!
Hold up.
Hi guys! Please hit like and subscribe and turn the notifications on for more information about mathematical logic. Thank you for watching. Bye!